Hello class, this is the video for section 4.3 and talks about the properties of rational functions. Okay, the following are our learning objectives. And one, we'll find the domain of rational functions. In fact, we did this in chapter 2, we'll revisit it, and then find the vertical asymptotes, and then also find the horizontal or oblique asymptotes of a rational function. Okay, so let's say here's the definition of a rational function. A rational function is of the form, is rational, like a rational number. But here, instead of having numbers, you have what? You have polynomials. So it's giving us so r of x is equal to p of x over q of x, where p and q, are your polynomials. Okay, where p and q are polynomials, they're polynomial functions. And then the domain of a rational functions are all real numbers except that the denominator q is not equal to what? It's not equal to 0. Okay. So now let's take some examples. What's the domain of this rational function? That's 3x squared minus 5 over x plus 2. So you take the denominator, x plus 2, set it to 0, and then solve. Now, when you solve, you have x is equal to 2, x is equal to negative 2, and that gives you, the domain will be able to include all real numbers except x equals negative 2, okay? So you have that. Now, second one is that we are given f for r of x is a rational function, 1 over s squared minus 225. Okay, so what you do is that to find out, you have to factor this, the rational function. So if you factor, this is s squared minus 25, which is a difference of 2 squares. So that is 1 over x plus 5 times x minus 5. And so if you set each of them to 0, x minus 5 equal to 0, or x plus 5 equal to 0, you get x is equal to minus 5 and then plus 5. So the domain will exclude all those values of x. Okay, and here is a third example. So we have r of x is equal to 2s cubed divided by s squared plus 1. Now, as you can see, if you take x squared plus 1 is set to 0, you have x squared is equal to negative 1, and x is equal to the square root of minus 1, okay, plus or minus. But you realize that it is not real. It's not a real number, okay? So there is no x value such that the denominator will go to 0. Therefore, the domain of this rational function is all real numbers. If you set in an interval notation, that's negative infinity to positive infinity. Okay, now when we talk about graphs of rational functions, all right, graphs of rational functions, there are certain things we should know that I want to bring it out. So graphs of rational functions often consist of several separate pieces of branches, okay? And then the graphs of rational functions may have vertical and horizontal asymptotes, or have vertical and then slant or oblique asymptotes. Okay, there is no rational function whose graph has both horizontal and then oblique. So either or. Okay, the asymptotes get very close to the graph gets very close to the asymptotes, but does not cross them, generally speaking. However, sometimes the graph may cross the horizontal asymptote. Okay, so here is some what we call reciprocal functions, or sometimes we call it reciprocal power functions. So let us recall the graph of f of x equal to 1 over x. Okay, now what is this graph? And it has certain properties. This graph is this, okay? This is the graph, all right? It's okay, this is your x, this is your y, and that is your x. Okay, if here's 1, and that is 1, so the graph passes through the point 1, 1, and also negative say -1, -1. Okay, it passes to these points. Okay, now you can see that the x and y axes are acting as what? Vertical and the horizontal asymptotes. See, the graph never touches the what? Never touches the y axis nor the what x axis, but get closer and closer and closer to it. Okay, there are certain properties that we should know. One, the vertical asymptote is the what? Is the y axis. The horizontal asymptote is what? The x axis. And also it has no x and y intercepts. And then three, because this function, if I plug in f of -x, I'll get 1 over what? -x, which is equal to -1 over what? X, which is the same as minus what? F of x. So this is what? Say that f is what? Is odd. See that? So if it's odd, then it's symmetric with respect to the origin. Okay. Now, let's look at the function 1 over x squared. Okay. That's a reciprocal function, power function, 1 over x squared. Now, 1 over x squared, what is the graph? Okay. The graph looks like this. Okay. The graph is like that. Okay. It never what? Touches the x-axis, and this is your y, and then what? The x-axis. Okay. Now, if x is 1, it passes to this point what? 1, 1. And if it's -2, y is still what? So it passes to -1 and 1. So it passes to these 2 points. All right. Now, what are the properties of this? One, the vertical axis, the asymptote is what? Is the what? The y-axis. The horizontal is the what? The x-axis. It doesn't also have what? X and y intercepts. That's 3. And then 4, this function is even, because if you plug in -x as we did in chapter 2, okay, if you square this, you get the same 1 over what? X squared, which is equal to the f of x. So f of x here is even, and if it's even, it's symmetric with respect to what? The y-axis. That is why the graph looks like that. Okay. Now, in general, for any reciprocal function or power function 1 over x raised to n, where n is an integer greater than 0, it resembles the following. 1, if the graph of it resembles the graph of what? 1 over x squared if n is even function. In other words, it's going to be symmetric with respect to the y-axis, the no x and y intercepts, and then vertically the the y axis and then x-axis acts as vertical and the horizontal asymptote what? Respectively. Okay. On the other hand, if the n, the n, okay, is what? Is odd, then it resembles the graph of y equal to what? 1 over x, as we explained. Okay. So now let's use transformation to graph the following function. We have what? The graph the rational function 1 over x plus 1 all squared minus 2. Now we can talk about the transformations. In this case, what? It's going to shift to what? It's going to be left shift. Okay, left shift what? 1 unit. And it's going to go down what? 2 units. For which graph? Now look at this, because that is 2, it's going to resemble the graph of y is equal to 1 over what? X squared. It's an even function, symmetric with respect to x axis. Sorry, y axis. Okay. So we're going to start with what? What's the domain of this? That's the domain. If you take this and set it to 0, 1 plus x plus 1 equal to 0, you have x is equal to -1. It includes all x axis, all real numbers except what? X equal to -1. Well, we're going to start with the graph of what? Y is equal to 1 over x squared, because that's how it's going to resemble. Then we're going to shift this to what? To the left, 1 unit, and then down 2 units. Okay, so what happens? Well, as we said, this graph will contain the points what? 1, 1, and -1, +1. All right, this is the graph of 1 over x squared. Now we're going to shift it to the left, y unit. So it means that the vertical asymptote will move to the left. It will come to what? The line y is equal to x is equal to -1. So that's why we have the vertical asymptotes here. This is your vertical asymptote. That means that every point on the graph is going to move to the left 1. So you have 1, 1. When you move to the -1, 1, that is subtract 1 from the what? The x-axis, you get what? You get 0, you get 0, 1. That is why this point is what? Is that. And then also, if you subtract, you have -1, you subtract 1, you get -2. So that's why we have what? The coordinates are -2, 1. And then we're going to shift this to down. It means that the horizontal axis, or the horizontal asymptote will go down what? 2 units. And when we do that, we have what? This graph. Okay, everything goes down. That means that if you take this point, go down 2 units, you subtract what? 2 from what? The y coordinate. So 1 minus 2 will be -1. That's why we have the point what? -2, -1, and then 0, -1. And that gives you this graph. Okay, so that's the equation of the horizontal what? Asymptote is y is equal to what? -2. The equation of the vertical asymptote is what? X is equal to what? -1, as I've indicated over there. All right, now let's take another example. Say you have what? This graph. All right, that was the domain. Domain will be what? All real numbers. Okay, except what? Except what? X is equal to what? 2. Okay, or you want to say that it is what? X is such that X is not equal to what? Is equal to 2. Okay, so in this case, now look at this. All right, because that is 3 and it's odd, the degree over there was 3 and it's odd. This graph, okay, resembles the graph of what? Y is equal to 1 over what? 1 over x. Okay, so we're going to start with the graph of 1 over x. Okay, so we have, as we can see, we start with this graph and then we shift it what? 2 units. So shift 2 units, shift right. Actually, it's a horizontal shift right 2 or 2 units. Okay, so when we have this graph here, okay, we have this graph. Let's say this is 1. It's going to pass to this point with 1, 1. Okay, and then on this side too. Okay, it's going to pass to the point what? Negative 1, -1, like that. So you're going to shift it to the right 2 units. Then the vertical asymptote is going to move 1, 2. Okay, this is your 2. So you're going to use dotted lines to represent that. Okay, this is my vertical axis, which is what? X is equal to what? As a vertical asymptote, which is X is equal to what? The equation is X equal to 2. Okay, and this point 1, 1, because we shift it to the right, it becomes what? 3, 3, 1. So this is going to pass to this point. We're calling this 3, 1. And so it's going to come that way and passes through that. Okay, and then this point is a -1, -1. If you add a 2 to that, it's going to be what? +1, 1. Okay, that also pass to this point. And so finally you have what? This graph like that. Now, if we separate that, if we separate it, this is going to be, let me erase that, the vertical one. It has to be straight. Okay, so we have this. All right, so you get 1, 2, and 3. The vertical asymptote is this. It passes through. Okay, so this graph is going to be like this, and then it's going to come and go like that. Okay, this is your y-axis, and that's your x-axis. And this is the graph for what? The f of x, which is what? 1 over x minus 2 to the what? To the third. Okay, all right. Now, let's talk about how do you find the vertical asymptotes, all right? Well, all that you do is that this is a rational function, p of x over what? K of x, which are both what? polynomials, but they have to put in them in the lowest terms. In other words, you got to factor them. Factor this polynomial, because some of the factors will cancel out. Okay, now after you have done that, then you set each of the factors in the denominator to 0. And the x values that make the denominator 0 are your what? The vertical asymptotes. In other words, if you have the factor x minus what? R, then it means that x is equal to r is a vertical what? Asymptote. Okay, now let's take some examples. Well, we are given f of x. What are the factors of this? We need to factor this expression here. F of x is equal to s squared minus 25 over s squared plus 2x minus 35. So we need to factor this. So the numerator is what? It's a difference of 2 squares. So it'll be s plus 5, x minus what? 5. Then what about the denominator? Let's put s is a quadratic, so we can factor it. Okay, and this is plus what? Plus 5, and then minus. Okay, so that will be minus 5 plus 7. Okay, let me erase that. Okay, so you have, so this is minus 5 plus 7, because if you have 2 factors when you multiply, so minus 5 times 7 is negative 35, but when you add them, you get positive 2, and that gives me that. So notice that these factors will cancel out. So this results to what? X plus what? 5 divided by x plus what? 7. And so you're going to say that the line, okay, you're going to first set the x plus what? 7 to what? 0. You have x is equal to negative 7. So you say that the line, okay, x is equal to 7, negative 7, is what? The vertical what? Asymptote. I use VA for that. Okay, there's a vertical asymptote for this function. Okay, now another example. Okay, we have to always factor this. So you get x over, that's the first thing. This would be s squared minus 49 is the difference of 2 squares. So that would be x plus 7, x minus 7. Okay, so we take x plus 7 equal to 0, and then x minus 7 equal to 0. So you get x is equal to negative 7, x equal to positive 7. So the lines, okay, here the lines, x is equal to minus 7 and x is equal to positive 7 are the what? Are your vertical what? Asymptotes. Okay, so there are 2 of them here. Okay, there are 2 vertical what? Asymptotes if you graph this function. Okay, then C, let's just see, when we take s squared plus 9, the denominator, all right, and set it to 0, okay, we set it to 0. What we get x squared is equal to negative 9, x is equal to plus or minus the square root of 9. Okay, it is what? Not real number. Okay, so what is our conclusion? This function h of x has what? No vertical what? Asymptote. It has no vertical what? Asymptote. Okay, now let us talk about the horizontal asymptotes. All right, so you have the rational function where p of x is what? Expressed as what? an xn, all right, in that form. And then the q of x is what's another polynomial, bm xm plus bm minus 1 ... See that? So, but our main concern is what? This what? The leading terms of the numerator and the denominator. The numerator and the denominator, and also the degrees. Okay, so what's the degree of the numerator is what? Is n. The degree of the denominator is what? It is m. Okay, so note that the degree of the numerator is n, and the degree of the denominator is what? M. Now, there are 4 cases here, all right? First, if n is less than what? M. In other words, the degree of the numerator is less than the degree of the denominator, no matter what, whether by 1 or by 2 or by 3. Then the line y is equal to 0 is the horizontal asymptote. Now notice that the line y equal to 0 is the same as what? The x-axis. Okay. So it's the line y x-axis is all the line y equal to 0 is the what? The horizontal asymptote. That is one case. Case number 2. If the degrees are equal, okay, then the line y is equal to the ratio of the leading coefficients. Okay, the ratio of the leading what? Coefficients. All right, the ratio of the leading what? Coefficients. So if you go back here, all right, the leading coefficient for the ratio of the leading coefficient of the numerator is what? AN. The leading coefficient of the denominator is what? BM. All right. So if the degrees of the numerator and denominator are equal, then the line y is equal to what? Okay. The ratio of that is your horizontal asymptote. Okay. Now, case number 3. If the degree, okay, of the numerator is what? Is greater than the degree of the denominator by 1. Then we have the line, okay, y is equal to ax plus what? B is called the slant or what? The oblique what? Asymptote. And we find this line by what? Using the polynomial what? Division. Okay, we'll consider example. Then case number 4, if the degree of the numerator is greater than the degree of what? The denominator by 2 or more, then we say that the n, it doesn't have what? It has no horizontal asymptote nor oblique asymptote, but the hn behave, the n, the way it's going to behave will resemble the line what? Y is equal to an divided by what? Bn times x raised to n minus what? M. Okay. Now notice that, note, a rational function never has what? Both horizontal asymptote and then what? An oblique asymptote the same time. Okay. The rational function may have neither what? Horizontal nor oblique. It's possible that you can have that. Now let's take some examples. Now the question is, before we take examples, does the graph, remember I mentioned the graph may cross the horizontal asymptote. So does the graph cross the horizontal asymptote? And how do we answer that? Okay, suppose the line y is equal to b, where b is a constant, okay? B is a constant. It's a horizontal asymptote. So to find where the graph crosses the horizontal asymptote, okay, asymptote, solve for the value of for x such that in the equation f of x is equal to what? B. So f of x is your polynomial function, sorry, the rational function. And your y is equal to b is your the horizontal asymptote. So you take the original function and set it toward b and then solve it. So here, this is your original, okay, rational function. Not in the factored form, because if you're still going to factor in, if you can, not in what? In a factored form. Okay, so we're going to take examples now. So it said find the horizontal asymptotes, all right? If there's one, and then we'll see if it's going to cross. And for this particular function or rational function, I'll show you why we cannot find the horizontal based on what we have covered in this class. All right. Now, now look at the degree. Okay, the degree of the numerator is what? The degree of the numerator is what? Is 4. So in this case, your what? Your n is equal to 4. Your m is equal to 6. Okay, so you have n is what? Less than what? M. So the line y is equal to 0 or the x-axis, okay, is your what? Is the horizontal what? Asymptote. Okay, because the degree, that is case number what? I believe is the case number 1. All right. When the degree of the numerator is less than the degree of the denominator, the line y is equal to 0 is the horizontal asymptote. Now, the question is that does this cross? Does a graph cross the line y is equal to 0? Okay, so here you solve the equation r of x is equal to what? 0, which this 0 is what? Is that line. So we take 3x to the 4 minus 2x cubed minus x divided by x to the 6 plus 4x squared plus 8, you set it to 0. Now this over 1. If you cross multiply, you only have the numerator x to the 4 minus 2x what? Cube minus x equal to what? 0. Then the common factor is what? X, they have 3x to the third minus 2x squared minus 1 equals 0. So you have for x is equal to 0 or 3x cubed minus 2x squared minus 1 equals 0. Now to find the zeros of this function, it will require what? Section 4.6, okay, which we omit in this class. But at least when x is equal to 0, that is the origin, this gives me one solution. But there are other roots that we have to what? We have to solve for that, find the roots of that, and then, because I don't want to go into that, okay, for the other equation, that is 3x squared, x cubed minus 2x squared minus 1. I don't want to go into the solution because we don't even cover it at all in this class. But what you should know is that at least x equal to 0 is where the graph of what? R of x will cross. So at least we know that R of x, okay, crosses, okay, the horizontal asymptote at what? At x is equal to 0. So when x is equal to 0, what is y? Now you plug it back into the original, you're going to have what? 0 over 8, which is what? 0. So at the origin, it's going to cross it at one place. There are other places, others, by which we could get from what? This equation, by solving that equation. Okay, we're going to leave it like this, okay? Like that for now. Now, second, okay, it said, another example, find the horizontal asymptote or oblique asymptote if one exists of the graph of this function, h of x. Okay, now look at this degree. The degree of the numerator, n, is what? 3. All right. The degree of the denominator is what? Is 2. Okay. We know that 3 is greater than 2 by what? By 1. Okay. So this will have what? It will have oblique. Okay. H of x, okay, will have an what? Oblique. That's what we call it. An oblique or slant asymptote. Okay, now how do you find that? Well, we need to divide this expression. Okay, we will divide this by that. Okay, well, as we explained, I said that this half will have an oblique asymptote. So let's go and divide this, find the oblique asymptote. All right, so here is we're going to divide, we take the numerator, okay, the denominator is x what? Is 2x cubed, okay, plus 3x squared, all right, and then we have plus what? Plus 2. There's a term is missing, so we have to introduce a missing term, which is what? 0x there, and we're going to divide this by what? It is x squared, okay, plus x, then plus what? Plus 1. So this goes into that how many times? Now, let us do the math. Okay. X squared goes into 2x cubed how many times? This would just be what? Okay, it will be just 2x, right? Because 2x times x cubed is what? 2x cubed. And then 2x times 1 is what? 2x squared. And then 2x times 1, it is what? It is what? 2x. Then what we do is that we're going to subtract. Okay, long division. We're going to subtract this. Well, 2x cubed minus that is 0. And this will be just what? X squared, because 3x squared minus 2x is x squared. Then this will be minus what? 2x. And then we drop this down, which is plus what? Plus 3. So again, x squared into x squared, how many times? That is positive 1, so that's plus 1. So 1 times x squared is what? X squared. 1 times x is what? Positive x. And then 1 times what? 1 times 1, it is what? It is 1. Okay, sorry, this is 2, not 3. Okay, so when you do this, let's subtract them again. Let's subtract it. This is 0. This is minus, so we have minus 2x minus x will be minus what? 3x. And they have 2 minus 1 is what? It is 1. Okay, so this is your remainder. That's your remainder. All right, so with the whole h of x can be expressed as what? The quotient, which is 2x plus 1, plus the remainder, which is negative 3x plus 1, divided by the what? The divisor. This is called the divisor. Okay, this is the quotient. Okay, that's the quotient. So you see that this is my quotient. This is my remainder. The numerator there is your remainder. Okay, and then that's the divisor. And this is your what? This is your quotient. Okay, so at the line, I have this in the next slide. The line y is equal to the quotient, which is 2x plus 1, is actually your what? Your oblique. Sorry, oblique what? Asymptote. Oblique asymptote. Okay. All right. So we say that the graph resembles this, meaning that this is your what? This is my what? Oblique what? Asymptote. Okay. All right. Here is another example. Okay. We have r of x rational function is equal to 9x squared minus x plus 1, and then 3x squared minus 2. Now notice that, okay, the degrees are the same. Okay, that is one of the cases. If the degrees are the same, my n is equal to 2, my m is equal to 2. They are equal. Okay. Now, if they are equal, if it says that if m, okay, n is equal to m, then the line y is equal to the ratio of the leading coefficients. So in this case, 9 over what? Over 3, which is what is called 3, is your what? Your horizontal asymptote. Okay, so we say that in this case, the line y equal to what? 3 is my what? Horizontal asymptote. So here we want to see if this function, this graph, where does it cross the x-axis? Sorry, where does it cross the horizontal axis, which is what? Y equal to what? 3. All right, so let's answer that question. Does the graph cross it? Now, what we do is that, well, we have what? R of x. Okay, let's go by the R of x is what? It's 9x squared minus x plus what? Plus 1. Okay, so it is what? 9x squared minus x plus 1 divided by 3x squared minus 2. Okay, let's make sure that I have that 9x squared minus x plus 1. Okay, so what we do is that we solve the equation. we know that the y is equal to 3 is what? Is the horizontal asymptote. So then we solve the equation. We solve what? R of x is equal to 3. This 3 is equal to 3. And so we have 9x squared minus x plus 1 divided by 3x squared minus 2 is equal to this 3 over 1. So let's cross multiply. When you cross multiply, you have what? 9x squared minus x plus 1 times 1 is equal to 3 times 3x squared minus 2. Okay, 1 times anything is the same thing. So that is 9x squared minus x plus 1 is equal to 3 times, that'd be 9x squared minus what? Minus 6. All right. So if you subtract minus 9x squared from both sides, okay, this will cancel out. So you only have what? Minus x plus 1 is equal to what? Negative 6. So minus x is equal to negative 6 minus 1, which is what? Negative 7. And then you have for divide both sides by negative 1, have x is equal to what? 7. Okay. So the point, the graph, you say that the graph of R of x, okay, crosses the horizontal asymptote at the point when x coordinate is what? 7, the y coordinate will be 3 because you equated it to what? Equal to 3. It's equal to 3. Or if you want to check, if you plug in 7 into the original and evaluate, you get 3. So this is where the graph will cross the what? The x-axis. Okay, very good. Now, finally, it says find the horizontal asymptote or oblique asymptote if one exists, right? Now look at it. This graph, the degree, your n is what? Is 5. The degree of the denominator is what? Is 3. Okay, you see that 5 is greater than 3 by what? By 2. So we have 2 or more. It means that it has no horizontal and oblique asymptotes, but the end behavior is like that. So when you have this, okay, since the degree of the numerator is 5, is greater than the degree of the denominator 3 by more than 1, okay, the rational function g has no what? Horizontal asymptote or oblique asymptote, okay? But the end behavior is going to behave like what? 10 over, this is 1. There's 1, which would be 10 over 1 raised times x raised to what? N minus m. N minus m. So that gives me, it's going to behave like what? This function. So it's going to rises to the both ends. Rises both ends. Both sides, if you want to call that. Okay. So that is that's the end of this section, and 4.4 will come soon. Thank you.